Welcome to everybody. I start the talk about abstract-based classes. This is the agenda. I tell about me, a small recap about base classes, XPath and the library that support that I develop. Then the tricks that I adopted for resolve difficult challenges in my libraries, about regex translator, and then the implementation of XML schema data types, and then the conclusions. About me, I'm a system administrator and then a developer, Python developer, at CISA, that is an international school that provide PhD courses in for mathematics, neuroscience, and physics. We have about 280 PhD students, also a master for communication of science. Our research institution has been founded in 1978, and the research lines are on astroparticle, many cognitive neuroscience, many of them in the areas that I tell. A small recap about base classes has been proposed in 2017. The proposal is for have a way to overload instance and subclasses. A new module that supports a framework for defining metaclasses and ABC, and a decorator for define abstract modules in more strict way. There are many ABCs for containers and iterators in a collections.abc module. How to define an abstract-based classes for who that never see that. You can import the ABC-based classes and then derive your own ABC. Otherwise, you can you can define your ABC with using the meta class ABC meta. The type of an ABC is not the basic type for objects, and is ABC meta for whom that never have seen meta classes, worked with meta classes. Be careful of meta classes conflicts. If you have to use them, you have to provide, you have to put careful in defining your own meta class. So better to derive from ABC meta your own particular meta class if you have to do that. Characteristics important of metaclasses, ABC metaclasses, are virtual subclass. So you can override the standard class hierarchy, and using a subclass hook, that is a dunder method that you can define in your meta class. Another way is to register you can register, show here, if you have a meta class derived for abstract meta class, you can register, in this example, a tuple as a subclass for of your ABC, and also is instance, an instance of tuple is also an instance of your defined abstract metaclass. abstract-based class. Okay. Abstract methods force you to define a set of methods that you have defined as abstracts before instantiate classes, objects of these classes, of this class. Last, about collection.abc is a collection of abstract-based classes for containers, and you can use you can have three many options for using ABCs, deriving directly from one of the classes provided by the collection, or you define a class that define all the methods of the ABC and use the virtual subclass registration and test the compatibility with the instance and this subclass. Or define a class in a more simple way that has at least the methods required to pass this instance and is a subclass checks against the ABC. For my case, I use direct derivation, and the best fitting cases I have a structured I have to develop XPath and support XPath parsing, and I use these classes for deriving my types and provide a dynamic programming generation of tokens. In these cases, I think that abstract-based classes are particularly useful because, as you can see, there are some abstract methods, and these methods are the only methods that you have to implement. The other methods, mixing methods, you don't need to do that. So there is less code to implement. As in this case, an example of a minimal implementation of a mutable sequence that is a list. In this case, implementing only this code, you have a full working replacement of a custom list that is also compatible in all the way with other methods. In this case, the list is also a mutable sequence, so you can use mutable sequence as a base class for type checking instead of lists. Now I go to the implementation about XPath and the element path library. A timeline for this activity. I started coding on Python for this, implementing validation decoding the XML data for Quantum Espresso suite, that is a Fortran suite for quantum simulation that is widely used in the community. They need Python as for testing and for validation of XML data produced by the codes. In 2016, I published the first library that is XML schema, and in 2018 I derived a specific dependent base package for element path. Both libraries are now in the catalog of Italian software as required by laws. XPath and XML languages. On the left, there is the historical vision about the development of these languages. On the right, after expat 2.0 and next implementation, the graph is on the right, where Xlink has been replaced by XML schema. XPath is still the core of the processing of these languages. The first challenge was about implementing the processing of XML regular expressions. In XML, there are some tokens, some definitions, extensions of regular expressions for matching name and Unicode XML name patterns. As you can see, in XML schema, there are many in the base definition, in the meta schema of XML schema. There are also base definitions of these patterns, particularly the shorthand \C and \I are new and only in XML regular expression definition. These expressions are used also in XPath 2.0 and XQuery 1.0 functions, in these functions. So after initial develop, appeared clear to me that there is no way without to support a validator for XML schema and then for XPath without implementing a solution for that. Some challenges on that are simple and are defined in the definition of XML schema regular expression. You can replace the shorthand \I with a string, with a set of a character set, a class with this string, and also for the shorthand \C. The other challenges are more complicated, and particularly the last, that the standard for regular expression in XML require the parsing of character class abstractions. That can be complicated because it can be nested. Also, there are negated form of previous character class, and so the problem is that operations are on all the Unicode character set, so the subset of character set that you have to process can be very wide. At last, the implementation support in the element path.regex subpackage. The translation process is about the regex is parsed for tokens that are not defined in the Python regex engine. Parsed tokens are replaced with the appropriate subset of Unicode characters. The resulting expression is then compiled and used in XML schema processing. There is the import that are relevant for implementation. The problem of Unicode characters there are currently about 150,000 characters defined, assigned. Each assigned character has a unique identifier name and is mapped to a unique immutable code point. Python 3.8 supports the Unicode Character Database 12.1. The 3.12 is compiled with Unicode version 15. Code points. There are more than 1 million code points. Most of them are not assigned yet, but is increasing version by version. At each code point is assigned a general category, and this is the main challenge to resolve. You can support the processing of XML regular expression, processing these subsets. Or in other implementation, I saw that they have used a tricks similar, because processing all the Unicode categories row with the subsets involve the problems of memory. Also about memory usage of dictionaries for storing these categories. At least you have to use about 10, 12 megabytes for a subset for all the categories. You have also to process them, and this is a problem. To resolve that, about abstract base classes, particularly useful has been for me to implement a mutable set, that abstract base class from abstract base class, processing not the whole set, but only a subset of intervals, because the characteristics that permit to do that is the fact that code points are grouped in about 6,000 intervals, so it's processable, and most of them are in undefined set. So using a list, an ordered list, I can process as a set with a full API of a set the operations that I need to do to process XML regular expressions. Profiling this Unicode subset as for verify if it's usable in terms of time, in terms of memory, the memory impact is very low, and the time is acceptable. With the Unicode subset, I can also process intermediate operations and create the list is longer, but use a Unicode subset to create at import time all the subset that I need to process the regex to process the results. I compile the regex. The translate is a function that returns a Python regex that can be long, but is compiled by Python and then used in XML schema. So in the case that I just illustrated, the abstract base class of mutable set has been useful for providing less code and to be sure that the subset that is produced is full operational with the setup API in terms of characters or in terms of code points. The second challenge is about atomic types and the expat data model. On the right, there are the XSD 1.1 hierarchy of types. There are some problems about that because any atomic type is the root type of any atomic types in XSD, but it's not instantiable. Also, I have to support in XPath untyped atomic and numeric that are not. Untyped atomic is another type that is not in XML schema, and the numeric is only for checking numeric data. So the solution, other challenges, is about that double and float are different types in XML schema. Is Boolean is not an integer. Also, integer is a subtype of decimal. And requirement is about the will of using basic data types whenever possible, because at that point that I did this implementation, the libraries are already used by many programs. Where are XML schema XPath types used in XPath? Are used in some their instructions of the language, or for specific conversion casting of type, instance checks, or to check if a type is usable as another. The implementation uses abstract-based classes using the ABC meta, in this case, to override the instance check of that is the main, the specific characteristic of abstract-based classes, and this was very useful to implement this. Otherwise, I cannot imagine how I could do that, because the instance check is explicit in XPath, and so I have to reproduce this case in my code. I derived a meta class for doing that, and then the atomic type. The implementation of float has been with another, I derived directly from an atomic type in this case, in some cases, and float has a pair of classes for processing the creation and the validation of the data. The meta class provides also a return back, a validation is valid, invalid type, and some other things to, okay. Now to the other implementation. I describe only this about the I defined some proxy classes derived from any atomic type because I don't want to replace the basic data types, but I need the checks of under the type system that I've defined. So XS Boolean is validated. The creation of instance is done by a Boolean proxy that returns a Python Boolean. The subclass hook permits to check the instance. Solution for string types is a bit complicated because I wanted to use a basic Python data type. So I derived the normalized string that is the direct derivation from string, the first derivation from string, both from string and atomic type, any atomic type. In this case, I provided validation, and well, it's a bit complicated to describe here, but also in this case, a proxy type permits to validate that. Solution for integer, similar to this. Also, I used the subclass hook to check the types and that it is not a Boolean. Conclusion about that: if you have to implement a complicated hierarchy of custom types, abstract base classes can give you flexibility to override, and it is the only way to do that that I found. Other checks on types is very, very complicated on values, and so make the code, the program slower, and reduce the code provided from necessary to implement your solution. This is the total. These are the totals for the subpackages. regex subpackages has about 2,000 lines of code that are 2 or 3 less than the other implementation that I saw that are Java in these cases. Data types, implementation is full, supported, okay, is finished, and I finished. And particularly important, the implementation is full about also the date time types that are an extended version of date time of Python with checking of time zone and with dates before the common era that are full supported. I pass with this package. Thank you for your attention. Now the package support about there are about 50,000 tests of XPath 2 and then more for XPath 3 and 3.1. Okay, thank you for your attention. Sorry for the English. For my if there is one question. Okay.
Thank you very much. So we maybe have time for one question if you have it live. Okay. We have no questions online. Thank you.